All right, let's dive right in. Today, we're going to look at a fundamental design choice that splits some of the ocean's greatest animals into two totally different families. We're talking about the choice between a skeleton made of flexible cartilage versus one made of hardened bone. So let me ask you something. Picture a great white shark, a super fast tuna, and, well, yourself. What in the world could possibly link the three of you? The answer is actually way deeper than you might think, and it all comes down to a shared ancient blueprint. And that blueprint has a name, Phylum Chordata. You can think of it as this exclusive biological club that we, and sharks, and tuna all belong to. So what does it take to get in? What are the membership requirements? Well, it all kicks off with this thing called the notochord. Just think of it as the body's very first piece of scaffolding. It's this flexible rod that gives the body its basic support. And every single chordate has one, at least when they're first developing. It's the foundational sketch that the rest of the body is built on. And this list of features? It isn't just for fish. This is the core checklist for the entire club. And yep, that includes pharyngeal slits, which turn into gills for fish, and even a postanal tail. Believe it or not, when you were a tiny embryo, you checked every single one of these boxes. We are all cut from the same biological cloth.
Okay, so now that we know we're all starting from the same basic plan, let's see where things start to diverge. It's time to meet the first major variation, the masters of an ancient and super efficient design, the cartilaginous fish, also known as Chondrichthyes.
And the headliners for this group are, of course, the ones you already know and love, the sharks and their flattened, bottom-dwelling relatives, the skates. These guys are the living, breathing ambassadors of the cartilage design. So what's their whole deal? The most important thing, the real game changer, is their skeleton. It's made completely of cartilage, which is way lighter and more flexible than bone. Also, notice those exposed gills. You know, the iconic slits you see on the side of a shark. They don't have any kind of protective cover. It's all part of their unique, sleek approach to ruling the seas. And here's another really unique feature they have, the cloaca. You can think of this thing as an evolutionary Swiss Army knife. It's a single, all-in-one exit for the reproductive, excretory, and digestive systems. I mean, talk about efficiency. It's a pretty clever piece of biological engineering. Okay, let's pivot and talk about the other great dynasty of fish. If the cartilage crew are the ancient masters, then the Osteichthyes, or the bony fish, are the modern, incredibly successful rulers of pretty much every body of water on Earth. And this group? It includes basically any fish you can name off the top of your head. We're talking about powerful tuna, the super common carp, and this huge family of marine fish called Cartilaginous. Their success is just undeniable. And right away, you can see the huge contrast. Their skeleton is made of real hardened bone, which gives them a super rigid structure. Their gills are protected by a little bony flap called an operculum, and their tail fin is perfectly symmetrical. They took that exact same chordate blueprint and went in a completely different direction. Now, one of their absolute greatest innovations is the swim bladder. This thing is basically a precision-engineered internal life vest. By changing the amount of gas inside, a bony fish can just hover effortlessly at any depth. That is a massive advantage that the cartilage crew just doesn't have.
Okay, now that we've met both teams, it's time for the main event. Let's put them head-to-head in a little face-off to really drive home what makes them so different.
First up, the big one, the skeleton. On one side, you've got the flexible, lightweight design of cartilage. On the other, the strong, rigid support of bone. These are two totally different philosophies for how to build a body.
Next, let's talk about breathing. The cartilage crew has those iconic open gill slits, but the bone brigade, they evolved this protective bony gill cover, the operculum, which does double duty. It not only protects their gills, but it also helps them pump water over them, even when they're sitting still. And now for the engine, the tail. A shark's asymmetrical tail provides both lift and forward thrust, which is pretty handy. But a tuna's symmetrical tail is a different beast altogether. It's optimized for one thing and one thing only, pure, unadulterated forward power. This little difference has a huge impact on how they move. So let's just pull it all together in one spot. Cartilage versus bone, exposed gills versus a protective cover, using an oily liver to stay buoyant versus a high-tech swim bladder. They started from the very same blueprint, but ended up with two masterful and profoundly different strategies for making a living underwater. And that brings us to the big final thought. You've got this ancient, brutally efficient design of the shark, a survivor for hundreds of millions of years. And then you have the sheer, overwhelming numbers and diversity of the bony fish. So which blueprint is truly dominant? Which one is better? Maybe the real answer is that they both are. They're two perfect solutions, two winning strategies in the incredible story of life. What do you think?